Hi, I'm Nadine.
And I'm Lillian, and today we're going to demonstrate how the Coriolis Force works. Many things spin. Nadine spins.
Lillian spins.
Most importantly, the Earth spins.
The Coriolis Force is created by the spinning of the Earth.
The effect of the Coriolis Force is an apparent deflection of the path of an object that moves within a rotating coordinate system.
The object does not actually deviate from its path, but it appears to do so because of the motion of the coordinate system. By coordinate system, we are referring to the Earth.
In order to demonstrate how the Coriolis Force affects objects in motion on Earth, we have a few demonstrations. We'll model the rotation of the Earth with a spinning plate and use a marble to demonstrate how it moves with rotation.
In our first demonstration, we'll see what happens when we roll a marble across the surface of the plate without rotation. As we can see, the marble rolls in a straight line.
When we add rotation and film from a stationary position, the ball rolls in a straight line across the plate. You can imagine this perspective as if we were watching the Earth rotating from the moon.
Now let's change the perspective so that we are filming from inside the reference frame of the rotating plate. Instead of rolling across the plate in a straight line, the marble is deflected by the rotation and rolls in a curved path.
Now that we've seen how rotation affects the trajectory of an object outside the reference frame and inside the reference frame, let's talk about how Coriolis effect plays out on Earth in real scenarios. In the northern hemisphere, the Coriolis force will deflect objects to the right. And in the southern hemisphere, the Coriolis force will deflect objects to the left.
An example of this deflection is the rotation of a storm in the Gulf of Mexico. Here we have a low pressure system in blue, or a storm, and an area of high pressure in red. Because in a gradient things always move from high to low, air will flow from the area of high pressure to the area of low pressure. Because of the Coriolis force, air will be deflected to the right and cause a counterclockwise rotation.
The same thing happens in the southern hemisphere, but instead of the air being deflected to the right, it is now deflected to the left. This causes storms in the southern hemisphere to rotate clockwise. Okay. This is so hard! Do you want to spin?